Hello everyone. The topic I'm going to have discussed earlier, it is about unit operations in food processing, in which the topic is about evaporation. Previously, we have discussed what is evaporation, what are its definitions, and what is an evaporator, what is the purpose of evaporation, what are the processing factors, and what are the types of evaporation equipment. We have discussed till single effect evaporator. In this topic, we are going to discuss about multiple effect evaporators. Multiple effect evaporator. In a single effect evaporator, energy lost as vapor. However, in multiple effect, the latent heat of vapor leaving is not used but it is discarded. Much of this latent heat, however, can be recovered and reused employing a multi-effect evaporator. Here is the simple diagram of a multi-effect. In this, the feed is passed through a single effect and it causes evaporation, and the partial concentrated solution is passed through the another feed. And the steam, it is passed as vapor and it is taken as the another vapor feed. This is the simplified diagram of a forward feed triple effect evaporator. Here it is a double effect evaporator, triple, penta, and it goes on. Forward feed triple effect evaporator. If the feed to the first effect is nearing the boiling point of the pressure in the first effect, 1 kg of steam will evaporate almost 1 kg of water. The first effect operates at a temperature that is high enough that the evaporated water serves as the heating medium to the second effect. Here again, almost another kg of water is evaporated, which can then be used as heating medium to the third effect. As a very tough approximation, almost 3 kg of water will be evaporated for 1 kg of steam in a triple effect evaporator. Hence, the steam economy, which is kg vapor evaporated per kg steam used, is increased. This also holds approximately for more than 3 effects. However, the increased steam economy of a multiple effect evaporator is gained at the expense of the original first cost of these evaporators. This is the forward feed evaporator. In this, the fresh feed is added to the first effect and flows to the next in the same direction of the vapor flow. This method of operation is used when the feed is hot or when the first concentrated product may be damaged at high temperatures. The boiling temperatures decreases the effect to effect. This means that if the first effect is at P1, that is 1 atm pressure, then the last effect will be under vacuum at a pressure PA. Backward feed multiple effect evaporator. In this backward feed operation, for a triple effect evaporator, the fresh feed enters the last and coldest effect and continues until the concentrated product leaves the first effect. What they are saying is that the concentrated product feed is passed through backside of the evaporator and it passes through the front side, whereas steam passes through the front side and goes through backside. Backward feed multiple effect evaporator. This is the reverse feed, which is advantageous when the fresh feed is cold, since a small amount of liquid must be heated to higher temperatures in the second and first effects. However, liquid pumps must be used in each effect since the flow is from low to high pressure. The reverse feed method is also used when the concentrated product is highly viscous. The high temperatures in the early effect, it reduces the viscosity and give reasonable heat transfer coefficients. Open pan evaporator. This is the simplest, which consists of a container open to the atmosphere in which fluid is heated directly by a heating coil or external jacket. Here it has a low evaporation rate and a poor thermal economy. The advantage is that they are useful when low capacity units are required. Heating is not effective in large capacity units since the ratio of heat transfer surface to volume to the liquid is low. Used to concentrate tomato pulp, prepare soups and sauces, and boil marmalades and confectionery products. Plate type evaporator. It consists of a plate evaporator, separator, a feed, vapor, concentrate, steam, condensate, and excess vapor. It consists of a set of plates in units in which the vapor condenses in the channels formed between plates. The heated liquid boils on the surface of the plates, ascending and descending as a film. The liquid and vapor mixture it formed goes to a centrifugal evaporator. It is used to concentrate heat-sensitive products since high treatment velocities are achieved, allowing good heat transfer and short residence times of the product in the evaporator. It occupies little space on the floor and are easily manipulated for cleaning since setup and dismount are easy and quick. It is usually employed to concentrate coffee, soup, broth, light marmalades, and citric juices. Short tube horizontal evaporator. These are formed by a chamber in which the bottom of which is crossed by a bundle of interior horizontal tubes that circulate steam acting as a heating fluid. Above the tube is a space that allows the separation by gravity of drops carried by the vapor release at the base. In impact, slabs are managed in order to facilitate the separation and carrying away of tops. Since the tube bundle, it makes the circulation of liquid difficult. Poor heat transfer coefficients. Usually, it is employed for the concentration of low viscosity liquids. Short tube vertical evaporator. The heating steam, it condenses the outside tubes vertically arranged inside the evaporation chamber. This tube is called calandria. It has a large central return tube through which the liquid colder than the liquid circulates ascending tubes, thus forming natural circulation streams. The length of the tube is usually ranged between 0.5 to 2 meter with a diameter of 2.5 to 7.5 meter, while the central tube, it presents a transverse sectional between 25 to 45% of the total section occupied by the tubes. It causes adequate evaporation velocities for non-corrosive liquids with moderate viscosity. It is usually employed for concentration of sugarcane and beetroot juices, fruit juices, malt extracts, glucose, and salt. Long tube evaporators. Once inside these tubes, the liquid begins to boil, expand due to evaporation and vaporization yield, which circulate at high velocity and carry away the liquid, which continues concentrate as it moves downward. In this, the ascending falling film, it consists of ascending falling film. It has the overall heat transfer coefficient is high. In this, the residence time is of the liquid treated in the heating zone is short, and descendant film evaporators are widely used to concentrate milk products. Falling film evaporator. In this, the feed is performed at the top of the tubes, so the vapor formed descends through the center of the tubes as a jet at great velocity. Climbing up or ascending film evaporator. In this, the liquid enters the bottom of the tubes. Vapor bubbles that ascends to the center of the tube begin to form, creating a thin film on the tube wall ascends at greater velocity. Agitated thin film evaporator. In this, the main resistance of the transfer is on the liquid side. In this, the concentrated solution leaves the bottom and vapor leaves through the separator and out the top. This type of evaporator is highly useful for highly viscous materials since the heat transfer coefficient is greater than the forced circulation evaporators. Thank you.